So I'm going to put them aside. I recycled them, but just in case we need to go back to that. And every time after we go through the previous notes, I have a daily concept puzzle. If you can come up with a better name for it, please let me know. A binomial squared has or is what? Can anyone tell us what to write here? Binomial squared is a what? A binomial squared?
A trinomial.
Thank you very much. So a binomial squared, the sum or a difference, it doesn't matter. When we square it, we get 3 terms. Awesome. When graphing a piecewise defined function, its branches can or cannot overlap.
No.
Of course, they cannot. Because if they do, it's not a function. If I graph something like this, or something like this, and then something like this on top of it, this is terribly wrong. By the vertical line test, this is not a function. They can never overlap. Thank you. When graphing any function, we find the first.
Domain.
Thank you. The difference quotient. Can anyone dictate the difference quotient to us? And then we have to write what it represents.
F of x plus h minus f of x all divided by h.
Good. What does it represent? The
almost.
Yes.
What was the word
yes.
you used? The almost like exact speed at that second.
The almost.
And almost the slope of the tangent.
Yes, the almost the instantaneous rate of change. But almost is very important. It's not exact. We will see when it's exact. But right now it's not exact. We don't have everything. So it represents the almost, I'm going to erase this here. It represents almost the instantaneous rate of change of f of x. Something else follows here. Okay? So this is something very important, but I cannot talk about it just yet because we're not there yet. Okay? So this sentence doesn't really end here. It has a condition. Only in a certain condition, when the function, I want to say it, but I'm not going to write it because we are not there yet. Only when the function is differentiable at a point, right? So that's what it is. So we're going to discuss this. Just remember there is some condition there. 2 mandatory steps in finding this and simplifying the difference quotient. 1 and 2 in this particular order. What is the first thing mandatory that has to happen? If it doesn't happen, I know I have an error somewhere.
Everything without an h.
All terms without h, yes. In the numerator.
H cancel out.
Numerator. Yes. All terms without h, simplify. If they don't, stop. Don't continue. It's a waste of time. Okay, what about the second one? If it doesn't happen, yes. Yes, age in the denominator
must be simplified.
Yes, must simplify. Very good. If any of these, and this is the correct order, of course, if any of this is not happening, stop. Don't continue. It will be a waste of time. The whole thing is wrong. Okay, now I wanted to look at what we just had on the discussion. So is this correct?
No.
No, of course not. Remember, the square root of 4 times 9 can be replaced by the square root of 4 times the square root of 9, as long as these are all real numbers. Otherwise, it doesn't work. But 4 times 9 and 4 and 9 are real numbers, so yes, I can write this. I can write it also if I have 4 over 9. Yes, I have the square root of 4 over the square root of 9. But if I have positive or negative, or in other words, addition or subtraction, no. You cannot separate the radical if you have an addition of terms or subtraction of terms. Good. I'm going to jump to this third one and then come back here. Is this correct?
No.
No, of
No.
course not. We just wrote that a binomial squared is a trinomial. By trinomial, we mean 3 terms. So this will be x squared minus 2xy plus y squared. Good. Now let's look at the last one here, which is the middle one. Is this correct? So this was false. Anyone? Any opinions, please?
Mm,
Can anyone tell us anything about this? It's okay if you're wrong. Tell me whether you wrote false or true.
I wrote true.
Okay, so let's forget about the left-hand side first. Let's look at the right-hand side. 1 over a plus 1 over b. What do I have to find?
The LCD.
Good. What is it?
AB.
Aha. So then this one needs a b and this one needs an a. So this is a plus b. Is this the same thing with this?
No.
No. So remember, you cannot add quantities in the denominator and then split them like this. It's not possible. So all of them were false. Okay. Good. Moving on. And the floor is open for your questions. Any questions you may want to look at, or anything that you want to start with. If not, I will continue with another problem from 2.1. You probably noticed, I hope you did, the last video from last time is missing. Why? Because I recorded probably about 10 minutes, and then I didn't realize that the recording was on, and I had that session with my college algebra class for an hour, and it recorded the whole thing, and I didn't know how to cut it. So I'm sorry about that. So the last 10 minutes from last class are missing. But we're going to have a similar example today. Good. Any questions for me?
Yes, Professor. Can you do another difference quotient with having a denominator like 2x plus 1?
So what is the function?
X minus 2 over x plus 1. Yeah, let's do that.
So this was the homework for today?
No.
Okay. It doesn't matter. So I just want you to say one thing.
No.
The written homework solutions will always be posted after I will post them after the homework is due. So you want to determine the difference quotient for this function, right?
No.
So we start with the definition, f of x plus h minus f of x divided by h. We plug in x plus h minus 2, x plus h plus 1, minus x minus 2 over x plus 1 divided by h. Is this okay so far?
Yeah.
Okay. Then we need the least common denominator in the numerator. The denominator is h or h over 1. And the least common denominator in the numerator will be what is it? Anyone?
X plus h plus 1 times x plus 1.
Very good, awesome. It's not important, but I like the small one to be first, but it's not important, it's the same thing. So obviously this one needs to be multiplied by x plus 1, and this one needs to be multiplied by x plus h plus 1. Is this clear?
No, go for that last part again, please. Thanks.
This was multiplied by x plus 1. Now I have to multiply the numerator by the same thing. This was multiplied by x plus h plus 1. I have to multiply the numerator by the same thing.
Okay.
Is that okay?
Yes.
So now x to x, x squared, x to h plus xh, x multiplied by -2. 1 times x, 1 times h, and -2. So far, so good?
So good. Thanks.
Is that okay?
Yes.
Good. Negative x times x, negative x squared, negative x times h, negative x times 1, negative times -2 now, 2 times x, 2x, plus 2h, and plus 2. Remember, it's a difference quotient. If this does not happen, I'll say stop. I can't continue. I won't continue because this is mandatory. So let's see. The x squared with negative x squared, the xh with negative xh, the positive x with the negative x, the negative 2x with the positive 2x, the negative 2 with the positive 2. Let's see what is left. So I have an h plus 2h, which is 3h. So the first mandatory step happened. So I know that all terms without h disappeared. Even more than that, I don't care if it's more than that. So I have 3h over x plus 1 times x plus h plus 1. And now I flip times 1 over h. The second step happens. And always write 1, so you know it's not 0. So 3 over x plus 1, x plus h plus 1. Any questions on this? Is this okay?
Yes, please. Thank you. I was mixing up the steps. Thank you.
Thank you. That's how we learn. We practice, we learn, we do it again, we do it again, we do it again. Okay, so the next step, I have the book open. Yeah, I thought I had the book open. They logged me out, so allow me to go back in. They logged me out. I was idle for a while. One second, I'm almost there. Okay, putting in my password. Okay. It's thinking. Why is it taking so long? Okay, I'm sharing my screen finally. Please wait, logging in. All I need is the ebook. Okay, so I would like us to determine the slope of secant lines for one more question. If I remember correctly, we looked at problem 3 last time. And we determined the slope of the tangent line, and we did not determine this. Would you like me to work on this problem one more time, or you want us to choose a different problem? I'm asking because I did not manage to record it. I mean, I recorded it, but it was 2 hours long.
Read out the question again, please. Thanks.
Okay, so let's do that again. So we have a point. So this is problem 3 in 2.1, and we are given a point 2 comma -1, and we have y equals 1 over 1 minus x. And of course, Q is our point x comma 1 over 1 minus x. We are asked to find the slope of the secant line PQ for all those given entries. And then they're asking us to figure out the slope of the tangent line, and also find the equation of the tangent line to the curve at P, at the point P, 2 comma -1. Okay, so remember, these numbers have to be in the correct order. And last time I was showing you a table, and I'm going to put them in the correct order from the smallest to the largest. So 1.5, 1.9, 1.99, 1.999. I'm going to leave a space, and then I'll continue. I don't have enough room, so I'll continue underneath. And that was x, and of course I wrote y, but I don't really want y. I'll erase it, as you know. So then I have 2.001, and I have 2.01, and 2.1, and 2.5. So this is the correct order of x values. 1.5, 1.9, approaching 2, passing, so we don't really have the 2 in here, and I'll show you why we cannot even put it in. And then the numbers 2.001 are right after 2, and 2.01, and so on and so forth. So I don't graph the function, but what I'm saying is this is, let's say, it's point 2 comma -1, and this is point Q. Point Q is x 1 over 1 minus x. And all we are trying to determine is this when x is 1.5, this when x is 1.9, and so on and so forth. Okay? So in order to determine the slope of the secant line, PQ, so this is P, all we have to write is y2 minus y1 over x2 minus x1. So 1 over 1 minus x minus -1 divided by x minus 2. Yes, you can enter in here 1.5 and get the slope. So I'm going to erase this because I don't want y. I don't want to determine the y values. Should I? Nobody's asking for them. They're asking us to determine the slope of the secant line. So this will be an extra work for nothing. Can I do it? Yes. Will I want to? No. I want to determine the slope of the secant line. So slope PQ directly. So I'm going to erase that and skip y because nobody's asking me to determine the y value. So that's why I'm going to enter, and I did record this last time. I'm not going to record it again because I posted that video. I want directly. If you don't work on this problem with the procedure that I'm showing you, you will have more work to do, and you may not get the exact slopes. Okay? Y is not important. Do not plug in 1.5 in the y, in the function to find y. There is no need. All we want to is to determine the slopes from the beginning. So I'm going to enter this, but I have to be very careful how I enter it in the graphing calculator. So I have to have parentheses around the numerator, parentheses around the denominator, and obviously parentheses around the small denominator. So this was all recorded. I'm going to show it again. or simply copy the numbers. Is that okay if I copy the numbers? So this was 2, this was 1.111111, this was 0.10101, and this was 0.01001, and this was 0.9990001, and 0.990090, and 0.909091, and 0.666667. They wanted 6 decimal places. Okay, so now notice that from 1.5, 1.9, 1.99, 1.999, I'm getting very close to 2. 1.999999992. On this side, 2.001. The next one will be 2.00001, 0.00001, and I'm getting closer and closer to 2. Look at now at these numbers, at the slope of the secant line. Where are they going? What is the tendency here, or the trend? The trend from this side and the trend from this side. And what should I put here?
They're approaching 1.
Yes, they are from both sides. The numbers from both sides are approaching 1. Notice that you cannot plug in 2 here. How come? Why can't I plug in 2 here? What's going to happen if I plug in 2?
You have a denominator of 0.
Right. I'm going to get a big, big, big error. So if I share my screen, I don't think I used my calculator last night with the other students, but maybe I did. I don't remember. It's a different class. Yes, I did use it. So I don't have the function. I will have to put it back in. Okay. So I just wanted to show you that if you plug in 2, of course, it will scream at us. So now we know that the slope of the tangent at P is 1. So we have the point 2, -1, and we have the tangent. So now we can answer the third part, the part C of the problem. Remember, this is not a monologue. Please interrupt. This is not an interruption. Just say what you have to say. Unmute yourselves, please. This is not a monologue. So we have y minus y1 equals the slope times x minus x1, where the slope is 1, x1 is 2, y1 is -1. You can say this is how lazy people write it. Yes, it's possible, but I like it because I don't like nested parentheses. Y minus -1 is y plus 1. 1 in front doesn't matter, so this is x minus 2. I subtract 1. When I move one term from one side to the other, it changes its sign. So x minus 3. This is the equation of the tangent line to the graph of 1 over 1 minus x at the point 2, -1. So the slope of this line is 1, and the equation of this line is y equals x minus 3. Any questions for me on this problem?
Would you need to convert it to slope-intercept form, or would point-slope form be an accepted answer?
This is the point-slope form, and is never an accepted answer. Slope-intercept form is the accepted answer, unless it specifically says this. But if it doesn't say anything, we always want this. Very good question. Thank you. Do you think we can consider this done? Can we move on? I made some changes here with the cameras, and I'm not sure. Is this better? Can you see? Is it clear enough? If you pin the speaker, you will see this on the entire screen. Is everyone okay with this?